Hello all and welcome back. So in this video, let's continue our discussion on time complexity and learn about big O complexity. So now let us get started. Now in the last few videos, we have actually learned and majorly understand what we have to focus on. So we have seen that we have to talk in terms of operations and not the exact time because that is something which we cannot get. Then we have to make sure that we focus only on the highest power. And along with that, we don't care about the coefficient much. We are majorly interested to understand by what order does our input affects our time. So big O complexity is actually a notation through which we can find the worst case complexity for a given algorithm. So let me now help you to now let me just define what exactly big O complexity is. So big O complexity says that, let's say if I have for a particular algorithm bubble sort, we have something, the relation is something like this. So this I can say that bubble sort has a function on n which is equals to this function, right? Now big O complexity says that if some algorithm which we have written has a function f of n, right? Then to get its big O complexity, what we have to do is we have to define another function g of n and a constant c. Okay, so I will repeat it once again. What big O complexity says, the way it is defined is that for the worst case, if we have the function on which our bubble sort depends, or sorry, let's say an algorithm depends, to find its big O complexity, what we have to do is we have to make sure that we are able to come up with two things, which is a constant c and another function g of n. And if we are able to do this, if we are able to bound our function, right, then the time complexity of our algorithm A will be given by big O of Gn, right? Now I know that it might be a little bit confusing based on the way I have defined it mathematically. So let me give you an example. Let's assume that our f of n for any algorithm is 2n square plus 2. Now, because I am talking about the worst case complexity, that is what big O complexity actually means, I have to make sure that I am able to bound this function, right? I am able to bound this function and say that, hey, this particular function is never going to be above this relation c into n. Now, if I talk in this terms, if I actually talk in this term, then what I'm going to get is, if I take my g of n equals to n square and say my c I take equal to 3, then I can always say that my 2n square plus 2 is going to be less than this 3n square. Now g of n is actually n square, as you can see. So I can then say that the time complexity of this algorithm is going to be big O of n square, right? We can also understand this, that anyways this term will not having any effect. So if we are able to bound our overall function, then based on this particular function which we are getting, that is what our complexity is for my algorithm. So let me just explain you this visually as well. Just let me remove this. Great. So pay attention everyone, if I talk and explain the same thing visually, because of course that is very important. Then let's say if I have some function f of x, right? Let's say like this, f of n, right? Then I'm just drawing my 1 c into g of n function, which I can always say, so this is going to be my time, and for this is going to be my input. Now again, I don't care about the smaller input, so there can be some place where my f of n can be greater. Okay, so we say that point k. And we majorly say that for n greater than k, okay, n greater than equal to k, after this particular thing, after my c of gn is always greater than f of n, right? So in a way, I have actually put a limit on my function, right? Using that particular limit, if I'm able to get this g of n function, that is what I say complexity of my overall algorithm is, right? So again, you have to understand this thing, that this is how big O complexity is defined. Now we are going to do lots and lots of questions to actually find this. But the understanding, the idea is that because I am finding the worst case complexity, I have to make sure that I am able to upper bound my function. Okay. So this overall relation upper bounds my function, right? It is able to upper bound my function. In terms of intuitively understanding, you can just think of, like, let's say if you are a runner, and you have to tomorrow run 10 meter, let's say 100 meters. Okay. Then in terms of this particular thing, you can say that, hey, in the worst case, even in the worst case, I will not take more than 10 minutes to run this. Okay. Doesn't matter if you are even taking a single step in every second, doesn't matter like how you're running. Okay. You are saying that, hey, in the very much worst case, I will make sure that I'm able to complete this full race in 10 minutes. So you have actually upper bounded your overall time which you're going to take, right? In a similar way for algorithm, the time which basically depends on my input size, we have upper bounded that with respect to the relation. Okay, so that is what big O complexity is. It helps you to find out the worst case time complexity, how the time complexity actually is dependent on your input in the worst case. And majorly, we will always be focusing on the worst case only. That is something which we have seen as well. Because for the best or for the initial cases, the algorithms are actually not differentiable at all. For example, we saw that how merge sort and bubble sort for the first few 10, 100 and 1000 array size, they were able to run in quickly in same amount of time. Even sometimes bubble sort can run faster as well. Okay. So this is what your big O complexity is. Now again, we are going to use this understanding. To first form kind of a relation, some relation of this kind for our algorithms. Okay, this f of n relation based on the number of operations which are happening, and then using the big O understanding, the big O complexity, we are going to actually tell what exactly is the complexity of my algorithm. Okay, so I hope that is clear, everyone. Now in the next class, we are going to cover big omega. Okay, so please make sure that you see this video again if you have any doubt, and please actually understand the same thing using intuition, because this is something now which you have to explain a lot, as well as use a lot going forward in your code. Okay, so thank you.